Hi everyone. Here's a quick example of a straight line motion equation using the equations of motion. This one is question 9 from our exercise. Reading the question, it says a train moves 48 metres in the first 6 seconds of motion. So what I've done here is I've decided that the train starts from the origin of our coordinate system, so x0 equals 0 metres. After 6 seconds, that's what the 6 here, x6 means after 6 seconds, the train has travelled 48. Then it says the train travels 32 metres in the last 2 seconds of 12 seconds of travel. So the train travels for 12 seconds, x12, and x10, that's the last 2 seconds of travel. I don't know where it is on the x-axis at this point, and I don't know where it is at this point in relation to the origin, but I do know that it is 32 metres from this point at x10 to this point at x12. You have to read these questions very carefully sometimes to get what they're talking about. They did say that it was constant acceleration the entire time. They have not told us the starting velocity, and they have not told us the magnitude of that acceleration. That's our job to find that out. And we also have to state the total distance travelled. In other words, we have to find what x12 equals. So I'm going to use the equation of motion that s equals ut plus 1/2 at squared. Sorry, did I say s? For a moment I thought I forgot and thought that I was a physics teacher again. X equals ut plus 1/2 at squared. Now, there's no point substituting 0 for x and 0 for time. We just get a useless equation that says 0 equals 0. So let's substitute for 6. So if I substitute 48 metres for x and 6 for time, this will be 6 times, try that again, 6 is time, that'll be 6u plus, now time is 6, so 6 squared is 36, a half times that is 18a, and that's my first equation. 2 variables, 2 unknowns, that's alright. Now this next one's going to be a bit more challenging. I'll show a bit more detail for this one. I think that x12 subtract x10 equals 32. Well, what's x12? That would be 12 times u plus 1/2 times a times 12 squared. 12 squared is 144. 1/2 of that is 72a. Now I'll substitute 10 for time. 10 times u plus 1/2 by a by 10 squared. 10 squared is 100, a half of that is 50a equals 32. So 12 take 10, that's 2u. 72 take 50 is plus 22a equals 32. I might as well divide everything by 2, so u plus 11a equals 16. And now, isolating u, I'd have 16 minus 11a. Let's call that equation 2. I'm going to solve equation 1. Let me just go back and highlight equation 1. There it is. And equation 2. I have 2 different equations in the 2 unknowns, u and a. So I'll substitute u from equation 2 into equation 1 and solve simultaneously. Now what did equation 1 look like? It was 48 plus equals 6u, so 48 equals 6. Instead of u, I'll put 16 take 11a. And equation 1 finished with plus 18a. 6 times 16 is 96 minus 66a plus 18a. 48 take 96 is negative 48. Negative 66 plus 18. Oh, that's convenient. It's also negative 48. Pretty clearly, a equals 1 metre per second squared. Now, going back from equation 2 then, u equaled 16 take 11a. 16 take 11 by 1. U equals 5 metres per second. We have found the initial velocity. That's what we asked for. We also have to find the total displacement. So the total distance travelled is x12. So I'll go straight back to my equation of motion. ut plus 1/2 at squared. U is 5. T is 12. 1/2. Acceleration was 1, wasn't it? Yes. Acceleration is 1. Time is 12. 5 times 12 is 60. Now 12 squared is 144. Remember, half of that 72. So we have 132 metres as the displacement after 12 seconds. That's a nice illustration of how these sorts of questions can start with the equation of motion, but we ended up with simultaneous equations because they gave us all these funny little clues involved in the middle of the question. Right, that's it for now. Hope you'd enjoyed that. Have a try of a few more of the questions from that exercise on your own.